Hello and welcome to Steve's Physics channel. I'm Steve, and today we have a three-dimensional projectile motion problem, and it's a little tougher, but if you can handle some of the two-dimensional projectile motion that we've been doing in previous problems, you hopefully should be able to knock this one out no problem. And the problem in this case is you're facing north while kicking a field goal, and you're in the middle of the goalposts from 50 meters away. If the wind is blowing due west at a constant 1.25 meters per second, and you kick the ball straight ahead at an angle of 33 degrees above the horizon with a 35 meter per second kick, will it be good? And if so, how far above the bar will the kick sail? Go ahead, pause the video, try it by yourself, and when you're ready, I'll show you how I did it. Welcome back. Hopefully that wasn't too bad for you. The first thing I did, and like most all problems, I always like to state all of the given quantities that I know about a problem. So in this case, we know the wind, we know the angle, we know the velocity, we know the distance, and the dimensions are given to us in the picture, so we know whether or not it's going to be within the uprights or not. And after that, the next big thing to do would be to try and figure out the components, because in this case we know the angle of the kick, and we also know the initial velocity with which it was kicked, so we can use that to find the x and y components. So with this one, the x component will be 29.35 meters per second, and the y component will be 19.06 meters per second. So now that we have those x and y velocity components, we can use that to figure out how long it's going to take between when we kick the ball to when it's going to cross the goalposts. And we can do that using the simple distance is equal to velocity times time. And then we plug in what we know, and we solve for time, and time in this case is 1.7 seconds. Next thing we want to do with that 1.7 seconds is figure out how high in the air the ball is going to be at that point in time. To do this, we're just going to use the equation we've been using in a lot of other cases. Height is equal to velocity times time plus 1/2 at squared. Except in this case, we now know time, and we want to figure out height, so we're going to plug in everything else, and we find that the height is 18.24 meters. However, based on our dimensions from the picture before, we can figure out that the height of the ball is going to be 15.24 meters above the bar, which is exactly what they were asking for in the second part of the question. However, we still need to figure out if it's going to be within the uprights at this point in time. To do that, we're going to use the simple equation again, distance is equal to velocity times time. Except in this case, we're going to be looking in the x direction. And we know as long as the ball does not go more than 3 meters out to the side in the 1.7 seconds it's in the air, it should be within the uprights and therefore a good kick, because we already know it's above the bar. We plug in the velocity and the time, and when we do that, we get that the distance it travels in the horizontal direction is 2.125 meters, which, if we looked at the picture, is less than 3 meters. And so if it meets both of those criteria, it should be a good kick. Hopefully you were able to solve this problem without any trouble. If you do have any questions, please leave them in the comments below. I'll do my best to answer any and all of them. If you liked this video and it helped, please leave a thumbs up and share it with your friends. And until next time, have a great day.